Okay, so in just a few days, literally, our planet is getting a completely new set of eyes. It feels like a monumental leap in how we understand Earth.
It really is.
We're talking about the launch of NISAR, that's the NASA ISRO synthetic aperture radar satellite, a
Huh.
huge collaboration, right, between NASA and India's space agency, ISRO.
Massive one,
And
yes.
the mission goal is, well, it's designed to scan pretty much the entire Earth's surface every 12 days. And here's the really wild part. It can do it through clouds, rain, day or night. Doesn't matter.
That's the power of radar.
With its launch window set for July 30, 2025, I mean, this really feels like it could be a game changer. So, okay, let's unpack this. What makes this particular mission just so significant?
Well, what's truly striking about NISAR isn't just the technology itself, though that's amazing. It's the sheer scale of the international commitment behind it.
Right.
I mean, this is the most expensive Earth observation mission these two countries have ever built together. We're talking over $1.5 billion.
Wow. $1.5 billion. dollars.
Wow. Yeah. And that level of investment, it really underscores this joint recognition that, look, understanding our planet's dynamics, especially now with the climate changing so rapidly, it just requires these uh, unprecedented capabilities.
Uh-huh.
It's really a testament, I think, to what global science collaboration can achieve when you're tackling these huge universal challenges.
Okay, a $1.5 billion investment definitely signals how important this is, but you mentioned it can see through clouds, forests, even like glimpse beneath the surface of the ground.
Yeah.
That sounds almost sci-fi.
Yeah, yeah.
So how does NISAR actually manage that incredible feat? What's the core tech here?
It all comes down to its main instrument, synthetic aperture radar, or
Oh,
SAR.
SAR. Okay.
Yeah. So unlike, the normal optical satellites that basically work like cameras, needing sunlight and clear skies.
Right, like the Google Earth images we're used to. Yeah.
Exactly. SAR works completely differently. It actively sends out its own radar pulses. Think of it maybe less like seeing and more like echolocation,
Yeah.
but, on a planetary scale.
Okay, echolocation for Earth. I like that.
It emits these powerful radar signals down towards the Earth, and then it precisely measures the signals that bounce back. And by analyzing the time it takes for those pulses to return and the tiny shifts in their frequency, NISAR can build these incredibly detailed, like ultra-high resolution maps,
How high res are we talking?
precise down to a few centimeters.
Centimeters, seriously.
Seriously. It gives us this unprecedented level of detail about changes happening on the ground. And that's how it can penetrate cloud cover, see through dense trees, and even detect subtle ground movements that other sensors would just completely miss.
So it's not just punching through clouds, it's mapping the Earth with a precision that, well, it sounds like we just haven't had before.
Exactly.
That level of detail, down to centimeters, does that mean we can track things like, I don't know, tiny structural shifts in a bridge or really subtle changes in landscape that just went unnoticed before?
Absolutely. That centimeter level precision, that's what unlocks entirely new kinds of insights. It means we can track not just the big movements, but these extremely subtle shifts in the Earth's surface over time.
Like what specifically?
Like the slow creep of tectonic plates, for example,
Hmm.
or the precise way a volcano inflates slightly before an eruption, or even, the subtle sinking of land because groundwater is being pumped out.
Wow.
It takes us way beyond just seeing that something changed to understanding the really fine mechanics behind that change.
Okay, the applications for this must be huge then. Let's talk about what NISAR will actually track. What are some of the key things it's designed to keep its eyes on?
Well, NISAR is designed to be a really comprehensive planetary monitor. So, top of the list, tracking the melting of glaciers and ice sheets. It'll give us incredibly detailed data on how those critical systems are responding to climate change.
Which is obviously huge right now.
Absolutely critical. It will also monitor earthquakes, and not just mapping the damage after they strike, but, and this is really key, detecting the subtle ground deformation that often happens before a major quake.
Before. So, potential warning signs.
Exactly, giving us new insights into seismic hazards. It'll also track landslides, floods, rising sea levels, even the subtle changes in forests and wetlands, like how these huge carbon sinks kind of breathe through the seasons.
Ah, so tracking the carbon cycle in action.
Yeah, helping us understand global carbon cycles much better.
Yeah.
But it's important to clarify, this isn't about spying on people.
Right. Not surveillance of individuals.
No, no. It is fundamentally about the surveillance of planetary survival.
Yeah.
It's focused on the critical changes that affect, well, all life on Earth.
Surveillance of survival. That's a really powerful way to frame it. Not about human activity per se, but the planet's fundamental health.
Precisely.
So, sticking with climate for a second, what new knowledge will NISAR give us that we couldn't get before, especially with something as vast as, say, ice sheet melt?
Well, that unprecedented clarity isn't just a buzzword here. For ice sheets, it means we can go way beyond just tracking the overall edge retreating. NISAR will let us see precisely which specific glaciers are thinning the fastest. It can help identify new water flows under the ice, things we couldn't see before, and even detect previously unknown drivers of melting.
Hidden drivers?
Yeah, stuff that was just impossible to observe with optical sensors or even less precise radar. This builds like a true timeline of planetary change. It reveals these really complex interactions in our climate system.
So you can literally watch it happen.
You can watch it happen. Witnessing the precise dynamics of, say, Antarctica's ice retreat, or see exactly how river deltas are flooding over years, it provides this continuous high-res record. It acts as both a crucial, warning system and a historical record in the making.
Beyond those vital long-term climate insights, though, there's the immediate stuff, right? The urgent need for information when natural disasters hit.
Absolutely.
In those critical moments, minutes and hours can literally be the difference between life and death. How is NISAR going to change disaster response compared to what we have now?
Its rapid scanning capability is truly transformative for disaster response. Think about it. When a major earthquake hits, or an area is suddenly swamped by floods, NISAR can map the affected zones, pinpoint collapsed bridges, identify the precise epicenter of the quake all within hours.
Hours, not days.
Hours. Before NISAR, emergency responders might be relying on, scattered reports, maybe slower, less precise satellite images, often blocked by clouds or just useless at night.
Right, the classic problems.
Yeah. NISAR's all-weather day and night capability means we get critical, actionable data almost immediately. And in those moments, that fast, accurate assessment could absolutely mean the difference between a failed rescue attempt and a safe life.
That's incredibly impactful. But given this amazing precision and how often it scans every 12 days, you said.
That's right.
It must be generating just an absolutely mind-boggling amount of data.
Oh, yeah.
What are the challenges there? And just managing and making sense of it all? How do you even start to tackle petabytes of information?
You've really hit on one of the biggest challenges and honestly one of the biggest opportunities of this whole mission.
Okay.
NISAR is projected to generate petabytes of information. Just to give you a sense of scale, that's like streaming HD video continuously for over 1,000 years.
Wow. Okay, that's a lot.
It's a lot. This sheer volume is going to push even NASA's current data infrastructure right to its limits.
So how do you handle it?
Well, this is where things like artificial intelligence and machine learning become absolutely crucial.
AI comes into play.
It has to. AI isn't just like sorting the data. It's using these really sophisticated algorithms to spot subtle patterns in the radar returns that a human analyst might just completely miss.
Like all kinds of patterns.
Distinguishing between different types of ground movement, assessing how healthy vegetation is, maybe detecting hidden pockets of water, all with incredible speed and efficiency.
So it turns raw data into useful info, fast.
Exactly. It transforms that raw data deluge into actionable intelligence in near real time. It makes this mission as much about the future of big data analysis as it is about Earth science itself.
That real-time, actionable intelligence, it sounds like it leads us towards an even grander vision for how we monitor our planet. Is NISAR sort of a stepping stone to something even bigger?
It absolutely is, yeah. Many scientists see NISAR as the first major step toward creating a true digital twin of Earth.
A digital twin? What does that mean exactly?
Imagine a living 3D model of our entire planet that updates constantly in near real time, reflecting all these changes we've been talking about, from the slow creep of tectonic plates to flash floods, from forest respiration to glacier melt, all in one dynamic model.
A live 3D Earth model. That's ambitious.
It is. And critically, both India and the U.S. are committed to sharing this vast data set openly with the world.
Open data, that's huge.
It's huge. It means NISAR has the potential to fundamentally redefine how every nation understands its own environment and our shared global home.
So, if we just pull back for a second and look at the ultimate implications, gaining this kind of comprehensive, almost real-time perspective from space, what does it truly mean for us down here on Earth?
I think it means we're moving away from this fragmented view of our planet, looking at pieces here and there, towards an increasingly holistic and dynamic one.
Seeing the whole system.
Seeing the whole system and how it connects Look, Earth is changing at an unprecedented pace. We know that. And with NISAR, we're finally getting equipped to see exactly how, with a precision and a clarity we've simply never had before.
Right.
This isn't just about collecting more data points, it's about gaining the actual knowledge we need to anticipate, to mitigate, and hopefully to adapt to the challenges our changing planet is throwing at us.
So to sum up then, NISAR. It's this monumental global collaboration poised to give us these unprecedented capabilities to watch our changing planet.
That's
From precisely tracking the tiniest movements of tectonic plates and glaciers to mapping disaster zones with incredible speed, its insights seem invaluable,
Yeah.
both for understanding those big long-term climate shifts and for responding to immediate crises.
Absolutely. And as we've touched on this deep dive, it's really only scratching the surface of what becomes possible when humanity gains such powerful, all-seeing
Yeah.
eyes on Earth.
Yeah.
The implications for science, for disaster preparedness, for global cooperation, they're truly vast. It goes far beyond just the immediate data.
It really does. Which leaves us with a final thought to maybe mull over. What kind of world really opens up when we have something close to a real-time 3D digital twin of our entire planet right at our fingertips?
Yeah.
And maybe more importantly, what new responsibilities does that incredible level of knowledge bring to all of us?